So for chapter 29, today we're going to cover most part of, all of the development and most part of the pregnancy. Let's first look at the developmental history of a human. You can probably, before we delve into the details, I want to warn you, this is not really, the scale of this wheel is not actually, really scaled to the time. It's really scaled to the developmental stages. How many things happening, developmentally, right? So you start with actually here, the maturation of the gametes, right? So last week, we mainly talk about, right, the generation of the gametes in the male and female reproductive system, right? So that's the term called gametogenesis, right? So, and then today we're going to start with fertilization, right? When the sperm fertilizes the egg, right, what happens? Right, it's going to trigger the oocytes to finish the meiosis II, and then you're going to have fuse of the nuclei, right? And then to go back to the diploid, right? So the those sex cells, those gametes are haploid. Now you fuse the nuclei of them, they were back to diploid. And that's zygote. Zygote then go through, stages, then get to the, it's basically the division of the cells, right? And so this is the first 2 weeks are called pre-embryonic period. So in this stage, right, you basically only have the division of the cells. And at the end of the pre-embryonic stage, you end up with a blastocyst that have a inner cell mass, right? Inner cell mass is the one structure going to develop into embryo. And so from week 3 all the way to week 8, right? Here it's only how many weeks? 6 weeks, right? But then it takes up a lot of the this wheel. Why is that? Because this is actually the embryonic period. Is when you actually start from the cells, right? Just a mass of cells, then actually develop into a human-like fetus. And during this stage, not only you have the blastocyst, right, implanted into the embryo, into the endometrium of the uterus, you are actually also, the embryo is going to go through organogenesis. Basically, all the internal organs in the embryo start to development. Remember, we just talked about the reproductive system development, right? So that's from week 5 to 6, then to week 7 is when you start to have the differential development between male and female. Remember that? And so that's part of the organogenesis. Not only reproductive system, all the hearts, the kidney, all the organ systems start to develop in the embryonic state. Right? And then once you get to the fetal period, week 9 to 38, it's just all the organs continue on their journey to develop, right? And then by the end of the pregnancy, a new human is born into the world. You're going to say, well, I have heard pregnancy lasts for 40 weeks. Why you end here at 38 weeks? Well, the reason is we start the counting, right? Start from the fertilization. But a lot of times in the real world, some physicians, the OBGYNs, actually most of them, at least when I go through pregnancy, my doctor starts the counting, right? Not because at the time of the fertilization, but they start the counting like how many weeks you are in. Start with the last time you menstruate, of your menstruation. So that tends to be about 2 weeks, your last time menstruation. Remember the uterine cycle, right? The last time your menstruation is actually about 2 weeks before your ovulation and fertilization could happen. So that's basically adding another 2 weeks at the beginning of your pregnancy, right? So then if you count that way, because people don't really know when they ovulate, or after ovulation, fertilization usually happens, within 1 day, right? But then people, women generally are aware of their last time their menstruation. So that's why, traditionally pregnancy has been counted from the last time of your menstruation, not from your ovulation, because, everybody could be slightly different about exactly when they ovulate, even though, we said average, is day 14 of your menstrual cycle, right? But that's why the discrepancy usually we talk about 40-week pregnancy, not 38 weeks of pregnancy. But here, for the purpose of discussing the development, we are counting from the time of fertilization. Okay, so all those, first 2 weeks, pre-embryonic period is counting from the fertilization. All those numbers is counting from the fertilization. So then you have 38 weeks of pregnancy. Well, let's first look at what happens, right, at fertilization. We all know fertilization happens when the sperm fertilizes egg. But we also know the egg, when it's ovulated, secondary oocyte, it's not just the secondary oocytes get ovulated, right? It actually has a lot of associated cells. You have zona pellucida that's surrounding the secondary oocyte. You have a lot of cells, right? Kind of wrap around the zona pellucida. They are called corona radiata. Right, the sperms, in order for the sperms to get to the oocytes, will have to go through those 2 layers. Right, so then we know sperms can swim, right? Sperms actually can, know where they are going because of corona radiata. Actually, can secrete chemicals that's chemotaxic. So that's basically attracting the sperms, to the side of the oocytes, right? So that's a process that's, the sperms can remain viable for 3 and 4 days to go through all the structures in the female to get to the secondary oocyte. But the secondary oocyte can only remain viable for about 24 hours after ovulation. Right, but so when the sperm swim here by the motility, right, because it's been swimming, can actually get through the layer of the corona radiata. But, right, it has to use the acrosome, the chemical in the acrosome cap, to go through the zona pellucida, that layer. Okay, once it goes through that layer, right, to kind of eat away whatever is in its path, and when the first one penetrates the zona pellucida, is going to deposit its nucleus into the oocyte. Okay, so only when that's what we call fertilization. Only when that happens, the secondary oocyte is going to finish. See how it's stuck it's arrested in the metaphase 2? Then now it's going to finish the meiosis 2 and then generate basically another polar body, right? Initially, you only have a first polar body here. Now it finished the meiosis 2, generate another polar body, and ovum. And the ovum going to nucleus going to merge, right? Fuse together with the sperm nucleus, and then form zygote. Well, the challenge here is you really only want one sperm fertilized, deposit its nucleus into the secondary oocyte, right? You don't want to have more than one. You are going to have a lot of competitors of the sperms, right? So maybe they'll have only one that winning the race, right? But then the others are not too far behind. And so to prevent that from happening, actually after the first sperm deposit its nucleus into the oocyte, what that's going to trigger the zona palisada going to harden, going to harden. Then no other sperm going to be able to penetrate it. So then it hardens. It's kind of shield the oocyte, right? The fertilized egg going to be further approached by other sperm. So to ensure that there's only one sperm nucleus enters the secondary oocyte. Then you say, what about simultaneously you have multiple sperms fertilized? They all deposit their nucleus into the secondary oocyte. Well, because then the result is multiple sets of chromosomes, right? So it's basically going to result in automatic abortion. There's nothing going to develop into this because it's abnormal. It have an abnormal number of chromosomes. Well, now here we start from zygote, right? Zygote is forms after the fusion of the ovum and the sperm nuclei, right? Then now it's two sets of chromosomes going to be merged. Then you're again going to have 23 pairs that's diploid. And then it's going to be in the zona palisada, and this zygote is going to divide. Keep on dividing from 1 to 2, 2 to 4, 4 to 8. Then finally you're going to end up with a ball of cells that's called a morula. And notice here, they are still all in this zona palisada. So you have an increase in cell number, but without a growth in the structure size, right? Because it's limited by zona palisada. And all while this happens while the zygote, right, the fertilized eggs moving towards the uterus in the uterine tube. And then this, once it gets to the morula stage, is about the time there's about to enter the uterus, and the morula is going to get out of is going to degrade the zona palisada, get out of there, and then going to develop into a hollowed kind of blastocyst. Right, blastocyst is now have a hollowed cavity, right? That's blastocyst cavity. Has a surrounding layer of cells that's called the trophoblast, right? And then you have an inner cell mass called embryoblast that's going to develop into embryos later. So that's inner cell mass of the blastocyst are the pluripotent stem cells. They have any of those cells. If you take them out, they have the potential of developing into a embryo. So that's why it's called the embryonic stem cells, or pluripotent stem cells, because they are very powerful stem cells. They can develop into any kind of structure, any kind of organ in your body, or even into a complete, like a embryo. So that is, when we talk about biomedical research, we talk about embryonic stem cells research. That's where the stem cells come from. It's from the inside of those blastocysts. So it's basically you are taking cells from here, and that's where you get the embryonic stem cells. This in the lab we focus on this structure, right? All the different components and where they are, the transit routes, right? In terms of the reproductive system, right? So you can see the oocytes ovulated, then going to travel along the uterine tubes. Ovulation, the fertilization usually happens here. It's called the ambula region of the uterine tube, right? It's going to further travel, right? Then at the blastocyst stage is in the uterus, then it's going to burrow down the endometrium of the uterus, right? And it's going to implant. This process is called implantation. Basically, the blastocyst is going to attach to the endometrium, the functional layer, and it's going to burrow down. And so the to set the stage for the further development for the embryo stage. So be familiar for the lab. You have to be familiar with everything, all the structures labeled and the terms used to describe each structure, right? The cleavage, what is marula, where does everything happen, how long it takes it, right? So all of that you need to be familiar with. So it takes about a week for the fertilized egg to get to the uterus. Here I want to talk about, there's a clinical view, right? Talk about the infertility and infertility treatments. Well, essentially the infertility could come from any kind of causes, right? Involving in the development of the gametes, or this whole process of, whether the fertilization can happen or not, whether if the uterine tubes are blocked, right, then there's no way the sperms can get to the oocyte, so the fertilization wouldn't be able to happen. If there's anything hormonal changes, levels deficiency that affecting ovulation, the pregnancy won't happen. If there's anything with the low sperm quality, or sperm, could be the female have anti-sperm antibody, right? So that will be the availability of the sperm for fertilization to happen. Then you're going to have infertility issue. Abnormal sperms, right, or impaired sperm delivery could also contribute. So anything on the male side or the female side, right, there's multiple things could result in infertility. So how to treat the infertility? Well, you could have, if it's impaired sperm delivery, could have intrauterine insemination. If it's, the low sperm count, you could also do that, right? Then oral medication, right, can sometimes help you with the hormonal changes. And then in vitro fertilization, right, if you have blocked uterine tubes or ovulation disorders, you can basically collect the oocytes, right, from the female and do the fertilization outside of the body in a dish. And then once you have a developing embryo, right, the blastocyst, then you can implant and put the blastocyst directly into the uterus. Okay, if you have difficulty generating the oocyte, you could have a donor oocyte. You have difficulty with the sperms, then you can have a donor sperm. Use donor sperms. So there's multiple possible treatments to overcome depending on what exactly the issue caused infertility. Okay, so now we are getting into the uterus, blastocyst, right? It's going to attach to the endometrium layer, the functional layer of the endometrium, and then it's going to burrow itself into this functional layer and going to develop, into embryo. And also placenta is going to develop from this part of the trophoblast layer, right? And especially the syncytial trophoblast, right? That's a layer of the trophoblast going to together with the functional layer of the endometrium form placenta. So this diagram is also a diagram you have to know all the labelings, right, for the lab. You're going to do that practice and listen to the recording of the lab. I'm not going to spend too much time walking through all that. But here instead, I want to focus on the hormones side. Okay, so if you still remember, right, we have the uterine cycles. Right, this is day 6, day 7, right? That's kind of right in the middle of the uterine cycle, that will be correspond to the secretory phase of the uterine cycle, also correspond to the luteal phase of the uterine cycle. What happens in this time? So this is the time you have the thickening of the functional layers of the endometrium. So that's basically preparing you, right? The uterus prepared for implantation to happen. In addition, how the uterine, the endometrium actually, are so well prepared is under the influence of progesterone, right? Specifically progesterone. And progesterone is secreted by the corpus luteum, and that's why it's called luteal phase, right? It's the corpus luteum secreting the estrogen and progesterone. And we said if there's no implantation happens, right, then you're going to end up with a regression of the corpus luteum and to become corpus albicans, right? You're going to then have the drop of the progesterone and estrogen level, then the endometrium functional layer is going to shed. You're going to end up with menstruals. But then here, if implantation happens, now we're talking about if implantation happens, then there must be, in order for, you cannot have, the regression of the corpus luteum, because if you have that, you're going to have drop of the estrogen level and progesterone level. You are going to shed this functional layer, right? So we cannot allow that corpus luteum to regress. Then some signal have to come from the developing pre-embryo, right, to the corpus luteum, and then to make it, continue to develop, not regress. And what is that signal? Well, that signal is this hormone generated by the trophoblast. So trophoblast is this surrounding layer, not the inner cell layers. It's the trophoblast. It's the surrounding cells in the blastocyst. They are called trophoblast. They actually secrete this hormone called the human chorionic gonadotropin, HCG. So HCG is actually mimicking, structurally very similar to with the luteinizing hormone from the pituitary gland. So if you remember, LH is the one that actually going to function, right, to the on the ovary. And what's in the ovary now is the corpus luteum. So LH is going to stimulate the corpus luteum and to maintain the corpus luteum. So if you maintain the corpus luteum structure, the corpus luteum going to respond by continue to develop, secrete estrogen and progesterone, and then that's going to sustain the uterine lining. And so you can have the pre-embryo to barrel down to further develop into embryo, right? So this would continue for another 3 months. The corpus luteum will continue to secrete those hormones, right? And it's going to continue to maintain the uterine lining. You're going to say, well, what happens after those 3 months? Well, after those 3 months, you're going to actually have the placenta well developed. Then placenta is going to be the producer of estrogen and progesterone. You're going to have, it's going to take over the function of corpus luteum. But this is a diagram showing you, right? So if you start from ovulation, the implantation happened about 10 days after the ovulation, right? Then you start to have a dramatically high spike of HCG level. That's the one secreted by trophoblast, right? So that's an indication implantation happens, right? You need to maintain the functional layer of the endometrium, so then the developing embryo can continue to develop, can get the nutrient it needs from the functional layer of the endometrium. So you have this peak spike, high spike of the HCG, and that's what we usually use to detect pregnancy, right? So it's to detect the HCG level in the urine. Because it's so high, it's going to be cleared out by urine, right? It's not going to be completely reabsorbed. It's a lot of going to, lost in the urine. And so that's how you can detect it. You can pee on the stick, and how it's detected, pee on the stick, and the antibody on the stick is going to detect the hormone. And then so after, about 3 months, right, then placenta now is going to be able to produce estrogen and progesterone. So you can see the estrogen and progesterone are quite flat in the first 3 months, right? It's gradually increased, but then because it's produced by corpus luteum, right? It's mainly for sustaining secretion. But then once the placenta is fully developed, you can then take over. Placenta is much bigger and produces much more estrogen and progesterone. You can then start to see this high, gradually increase of the estrogen and progesterone level in the later, after in the second and third trimester of the pregnancy. And it's going to cause a lot of change in the pregnant mother, and to prepare, basically to prepare the mother for the growth of the fetus. So we're going to talk about all those hormones. What does those hormones do in the pregnancy? But here we're focused on the first early stage, right? Then it's mainly HCG spike, and the placenta is only going to take over after 3 months of pregnancy. I would like to summarize, right? There are a period of 2s in the second week of development, okay? So this is after the implantation, right? You are going to develop a 2-layered germinal disc, okay? That's coming from the embryoblast, from the inner cell mass, right? Instead of a mass, now it's going to develop into a 2-layered germinal discs. There are epiblast and hypoblast. Basically, one's on top, one's on at bottom, right? So then from those, then there's 2 extra embryonic membranes develop on either side of this bilaminar germinal disc. And so one of them is the yolk sac, right? The other one is the embryon. Okay, so yolk sac is important for early blood cell and blood vessel formation. So embryon is going to develop into, embryon is this membrane going to wrap around, right, the developing fetus in the later stage. And then also the placenta start to develop, right? That's from 2 components. Again, period of 2 components that eventually merge, right? One is the carrion from the preembryo, and the other one is the functional layer of the endometrium of the fetus. Let's see what that means. This is what we mean in the period of 2s, right? See the bilaminar germinal discs, right? So you have the hypoblastic, that's the one right next to the yolk sac. You have the epiblasts, that's right next to the amnion cavity, and amnion is this membrane here, right? So then that's the 2 extra embryonic membranes, and then you are starting to have the development of the placenta from the trophoblast and the uterine and the functional layer of the uterus tube. You're going to see that better in the next diagram. But that's the period of 2s. In week 3, we started to call it embryo stage, right? So now the 2 layers, a bilaminar layer becomes 3 layers, right? Trilaminar discs, and then it's going to so you have still the amnion and the yolk sac, then you have the carrion, right here, then it's going to develop those root-like structure, or called chorionic villi. It's going to expand deep into the functional layer of the endometrium, and so those 2 layers together are going to force develop into placenta later. So this is going to continue to develop. This initially in week 3 is inside, entirely buried in the endometrium, and then early week 4, right, is going to see the further development of the embryo, and the yolk sac is going to predominantly develop into blood vessels, and blood cells development going to contribute to that. I want to say something about this developing embryo. The 3 layers, germ layers, right? They are ectoderm, mesoderm is the one in the middle, and the endoderm is going to be the one going to be wrapped inside, right? So it's endoderm. So they are going to give rise to all of our organ system later in life. So ectoderm is going to develop into skin, ectoderm's outside surface, as well as, right, mainly the nervous tissue and sensory organs. So skin and nervous systems are going to develop from the ectoderm, and the mesoderm gives you, basically, your muscle, your connective tissue, right, heart, kidney, right, internal of the reproductive system, right, a lot of dermis of the skin is going to develop into from mesoderm. The ectoderm is basically all the internal lining of your organs, the epithelial lining, right, your respiratory system, GI tract, reproductive ducts, all those ducts and internal linings, that's going to be developed from the endoderm. Liver, gallbladder, right, all of those glands, right, most of the glands are going to develop from the endoderm too, because they are made out primarily of epithelial tissue. So you need to know what kind of organs roughly develop from which, germ layer. So your lab manual has a table for you to summarize that, but you also need to know that in terms of for the lecture exam. Right? Basically, ectoderm is easy. Endoderm is all the internal linings, right, and liver, and then and the glands, and everything else develop from the mesoderm, the middle layer.